Domain and range of functions. If we are given functions as equations in terms of x and y, we can write the domain and range as follows. And we want to be able to write them in both ways. We can use set builder notation, which we should know means if it's the domain, we would just say D and then colon, and then the set of all x's such that whatever is true about x, and then end your set. Okay, we've done this before. Interval notation is the same thing. The domain is going to equal, we know this is our x's, so we're going to be using our parentheses or our square brackets depending on if it's or equal to, or if it's just greater than or less than or whatever. Okay, so we have to be able to do both those. And range will be the same thing, except we'll say R colon the set of all y's such that, and then end your set. Or in set builder, or in interval notation rather, we're going to use our parentheses and our square brackets. Okay, so just make sure we're paying attention to which we're asking. Set builder notation, you got to have y such that, x such that, whatever. Interval notation, you just use your parentheses or square brackets. So in these examples, we want to find the domain and range in set builder and interval notation. So for this first one, set builder, what are my possible x's? My domain is the set of all x's such that we have an inequality. Now, it looks like the x's go left and right forever. So that would mean that x is equal to all real numbers. And that's your answer. Now, interval notation is a little bit different. So it's negative infinity to positive infinity. So we can never reach infinity, so we put parentheses. So the domain is equal to parentheses, negative infinity to positive infinity. Now, set builder notation for the range. So if I have the range, I have the set of all y's such that, now y cuts off here at 3. So 3 is the highest it can go. So it's x is less than or equal to positive 3. And that would be my set builder notation. Interval notation may be a little bit more difficult. So the range is equal to, it goes down to negative infinity, and it goes up to and includes 3. So I put a square bracket around the 3, and that would be your final answer there. This next one looks a little bit more difficult because we see an open circle and a closed circle and different things going on. So let's start with our domain. The set in set builder notation, the set of all x's such that, okay, so what is happening? We are going from negative infinity, so x must be less than something, and because it's an open circle, it's less than negative 2, because that's what my x is right there, and x is in between negative 2 and 1. So if I'm going to write that, then I want to write it as x, negative 2 is less than x, which is less than or equal to 1. And there's one more, because we also have this last one. Okay, so that would be x is greater than or equal to 1. So that would be my entire one. That's a big one. Okay, so now my domain in interval notation, so I go from negative infinity up to the negative 2, and I don't include the negative 2, so I leave that as a parentheses, union with negative 2 to 1, so parentheses, negative 2, comma 1, bracket, square bracket, because that's a closed circle, union with a 1 to positive infinity. Okay, and that would be a square bracket around the 1. Now for the range, if we want to find set builder notation, we have to say the set of all y's such that, and then write our inequality. So as we're looking at this, we see that it can go up forever and it can go down forever. So that means it can be any possible y value. So y is equal to all real numbers. And then end your set. Interval notation is slightly more difficult because we have to make sure that we include them all. So the range is equal to negative infinity, and we can't reach infinity, so you put a parentheses around there, up to positive infinity, and again, parentheses. Now in this case, you got to be careful because make sure that every point is included. There's an open circle on that negative 2, 2 point, but there's also a closed circle on 1, 2, so that y value is still accounted for. For this next example, we have endpoints, so we are not continuing on forever in either direction, domain or range. So we're going to have to be careful on both of them. So my domain for set builder notation is the set of all x's such that, what are the possible x's it could be? Well, it could go all the way to negative 4 here, and it goes up to 1, 2, 3, 4, 5. It looks like 5. But it's an open circle on 5. So what that means is negative 4 is less than or equal to x, which is less than 5. And then end your set. Interval notation of this, the domain is equal to square bracket around the negative 4, because it's including the negative 4, up to 5, with a parentheses around 5 because we are not including 5. Now, set builder notation for the range. The range is all y's, the set of all y's, such that the top end y is 3, and it comes all the way down to the lowest point, which is a negative 3. All right, so, and it includes both of those points. So my final answer would be negative 3 is less than or equal to y is less than or equal to positive 3. End my set. Interval notation of this, because both of them are less than or equal to, my range is going to equal square bracket negative 3 to 3 square bracket, because it includes both ends. That's it for your notes on domains and ranges of functions. Go through the practice problems. Make sure you understand both interval notation and set notation. We talked about them a little bit in the previous unit, but we really hit it hard in this lesson, so make sure you understand that, and then prepare for a quiz over this material.